matters. The problem is not about memory management, the problem is in order to kernel itself, in this case. So, okay, so if you run this query, you can see that the memory increases and increases until you hit basically the limit. Now when the memory is free, you're already at 6 MB and we started by 5 and so on. So, okay, you know that the PGA increases and increases, and you can also see it here. What is the next steps that you do?
PGA stuff. There is the option to look at which part is more increased.
Yeah, that's that. But you also want to drill down even more in detail, right?
I want to check what the session is doing for the SQL.
Of course, I use the snapper.
Okay, you use the snapper, okay.
Over debug directly.
Yeah, you can also start with already debug right there and look at heap dumps or something like that.
We can use trace 10046.
You can use PGA trace.
Or go to the operating system like vtrace or perf to see exactly where.
You can also go down, but let's make it a little bit more systematic. We just right now know that the PGA increases, and we have also the proof that it is doing it here with the session. And now we want to get a breakdown from this PGA memory usage. So we want to see if it's SQL based or PL/SQL based or whatever. So there's another view which you can use. I will run it several times. So it's $process_memory here. And with this view, you get a little bit more detailed information about the PGA breakdown. So this is still the PGA, and you have 4 categories: Freeable, Other, PL/SQL, and SQL.
Stefan, sorry that I'm breaking you. Could you please move that banner because
sure. Yeah, it's about the cloud. I have to remove it. Is it good?
Yeah.
Okay, great. Now we can do the rest. Okay, so you have 4 categories: Freeable, Other, PL/SQL, and SQL. Well, SQL is pretty logical. It's about work areas and hash joins and whatever. PL/SQL stuff, well, it's about PL/SQL. And others, it's others, right? And freeable means this memory, which is shown in the allocated column, is able to get back to the OS before it freezes. And if we run it once more, several times, you see, the other increases and increases.
Right? Sometimes it decreases.
Sorry?
Sometimes it decreases.
Yeah, but it's not the same like because it's free sometimes. But if you run it over time, if you monitor it, you will see that it will increase. And so we will need to analyze the other category in this case. And how can you get a more drilled down into this category? What do you usually do? I know Aura debug, we will do that later on. But you can also get more information from Aura itself without Aura debug or operating system tools. Exactly, yeah, exactly. So there is another view. I will explain what I do right now later on. So there's a view process memory_detail, where you get a little bit more breakdown of these different categories. And if you just select from this process view, the first thing is that you get no row selected. Why? Because this view needs to be populated by this process or by this session. And by default, it's not populated. And as I run in this SQL in a different session, it is not allowed to look into the other heap memory of this session. So this session needs to populate it. And there is an Aura debug command for it. And that's the reason why I entered here the PID from above, this 40 bits. Aura debug set mybit, and then I say to this process, please populate the details in process memory detail. And when I have done that, I will get something like this. Let's go up. So, and in this case, you can see the category once again, and you can see also the memory allocation reasons. In this case, case ZX A as input, whatever it is. And you can also see from which heap it is allocated, how much bytes, and the allocation count. So that's basically how much chunks are allocated. So that's basically the lowest levels that you can get from Oracle about this stuff. Okay. Basically, this process, which I used with Oracle debug PGA detail get, only populates this view when it gets active. But as my process is running the application, it always is active. So don't be confused when it's not populated immediately. It only gets populated on the next database call. So, okay, we know that when we run this several times again, we will see is that this memory allocation reason is increasing and increasing. So, what is it? It's critical, right? Okay, so how do we get more information about this stuff? Then we are at Aura debug, for example. So, Aura debug is pretty useful in this case because if you don't know what this critical stuff means, in most cases it has something in the brackets. So, you know, everything that starts with KZX, sorry, has something to do with XS, whatever it is, right? And if it starts with KZXA, it has something to do with XSS ACL. And in our application case, we are using ACLs because I'm doing web calls and so on. So that's one way you can do it to get a little bit more information. But there's also another great tool by Fritz Buchland, who's in the back. And he basically built a database, or created a database and still maintains it, where he puts all the information about C function calls and its prefixes stuff and so on. And in this case, it only includes the stuff from Aura debug, but in most of the other cases, or in several other cases, it has also more detailed information about this. And we will use this tool later on to get a little bit more information about other stuff, to drill down even more. Okay, so that's one way to do it. And now we will get to Aura debug to dump some heaps. We drilled down from the Oracle perspective, and now let's do the heap dumps to get a little bit more information about the allocations. Who of you have already worked with Aura debug and dump heaps? Okay, 4. Okay, it's not so much. Okay. So at first I gather some information. I use the OS pit to get some information about the visit is 23. Sorry. So I get some information about the sessions, and what I read right now is a OS pit from the server, so basically from the child process. So, and what I will do now right here is I set OS pit to this process ID. I use Aura debug to get the trace file name, and then I will dump now the PGA, right? With level 1. And when I add this level number here, I do not get only the top level heaps, but also 2 levels of recursive. So it basically means I get the top heap, the sub heap, and another sub heap. And now let's have a look at this trace file. There is a trace file analyzer by Koehler, which you can use to have a first look at this dump, which summarizes it basically. So, and you can basically see the same picture like what Oracle populated in this view. You can see this allocation reason, which is a little bit cut. And you can see from the heap and the total size, which basically matches the size from this $3 process detail view. But what you also can see is the chunk size. That's what that was missing in the other view. So each allocation of this, for this reason, is 80 bytes. And we will